Hey, this is the second video that deals with integer exponents and the rules that we use while we're talking about those exponents and little shortcuts that we can take and certain things that come up that we can fix before we work on them. So one of the things that happens if we're talking about integers as exponents, and you know, we're very comfortable with the 2 or the 3 because those are squares and cubes. And if we have, you know, something to the third power, you know, if we have 2 to the third power, we just take 2 times 2 times 2, and 2 times 2 times 2 is 8, and 2 cubed is 8. I mean, it's easy. 3 squared is going to be 3 times 3, which is 9. If you have 7 to the 5th power, things are very easy, very comfortable. It just means that there are going to be 5 sevens multiplied by each other. So even if it's tedious and kind of cumbersome, we still just multiply it out. So it'd be, you know, 7 times 7 times 7 times 7 times 7, and you can figure it out. Well, a couple of things that happen with integers, if you're talking about integers, we're talking about whole numbers, which everybody's kind of pretty comfortable with. Eventually what happens is you include other numbers in your as being an exponent, and some of them actually are decimals and fractions. So things get a little more complicated. In order to understand what you want to do with an exponent that becomes a decimal, or an exponent that is a decimal, like 5 to the 0.32 power, what do you do with that? Or 5 to the 2/3 power, what do you do with that? Or 5 to the 3/2 power? How in the world do we mess with that kind of stuff? Well, in order to do that, you need to understand what's going on with exponents of integers before we get into the other rational exponents, which would be decimals or fractions. And so we've already established the idea that if I have an exponent, or excuse me, I have a power that has it's a power times another power, which is we have the same base. We can just keep our base and then just add these exponents. So if it was 5 squared and 5 cubed, it would be 5 to the 5th, because 2 plus 3 is 5. If we have something that's like this, where we're dividing, it's going to be m minus n, or a to the m minus nth power. So again, a to the 5th minus, or excuse me, 5 to the 5th divided by 5 to the 3rd. 5 minus 2 would be 5 to the 2nd, or 5 squared. And then if we had this, a power to a power, this ends up being a to the m times n power, okay? Our exponent of m times n, because it's a to the m this many times. And then once we expand this out, it turns out that it's addition again. It just looks like this one is just written differently. You know, 2 to the 2nd power to the 3rd power would be 2 times 3, which would be 2 to the 6th. So every once in a while, what happens here is there's a special situation where we end up with something like this. And this is what's going to make things, this is what's going to make our argument. What if we had a to the m and we divided by a to the m? Well, a to the m over a to the m is 1 every single time. This is the thing that makes the argument that any exponent to the power of 0 is going to end up being 1. And this is how that would happen. If you had 3 to the 4th power over 3 to the 4th power, you could do this a couple of ways and prove that that's going to happen every single time. This expanded is 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3. Well, what's so special about 3 over 3? Well, it's a 1. This is a 1. So it's 1 times whatever's left, which doesn't change whatever's left. So, you know, through the multiplication by 1 is just It doesn't change it. So it's 1 times 1 times 1 times 1. So this whole thing ends up being 1. Well, let's look at it differently. What are our rules if we're dividing a power, dividing it by another one? And if we had 3, what we do is we subtract them. Well, what is m minus m? Well, m minus m is 0. So 3 to the 4th over 3 to the 4th is really 3 because the base is the same. And then you've got 4 minus 4 minus 4 for your exponent, which means 4 minus 4 is 0. So 3 to the 0th power. And we know that this ends up being 1. So 3 to the 0th power is really 1. Now, if you think about it, and just dwell upon this for a moment, what if I had a 5 here instead of 3's? It would end up being 1. If I had pi and pi, it would end up being 1. If I had a 10 and a 10, it would end up being 1. It doesn't matter if I had 5 and then these exponents were the same, I would end up with 1. And if these exponents are the same, if I had 2 to the 5th over 2 to the 5th, 5 minus 5 is 0. So if I have the same one power with an exponent, or with a base with an exponent over another base with the same exponent, and the bases are the same and the exponents are the same, I'm going to end up with 1. This minus this is 0. So it doesn't matter what number I have here. If I have both of these the same, I'm going to end up with that for an answer. And it can also be represented as 3 to the 0th or 10 to the 0th or x to the 0 power. So anything you ever see to the 0 power is 1 every single time. Okay. Now, I talked in the session that we had today about, well, what is 0 to the 0th power? Well, some people believe that 0 to the 0th power is 1, and some people believe that 0 to the 0 power, they make an argument that it's actually 0. It is my opinion that 0 to the 0th power is 1, because it would break, it would not fit in with all of the other values of 1 taken to the 0th power. It would be like the exception. Luckily, I've never had to solve a problem where 0 to the 0th power was there, so I've never had to deal with it. Okay, so, and I'm a mathematician, so how often do you think it's going to come up for you, right? But you should look online. There are some discussions online with some very practiced and educated mathematical professionals and professors and people at MIT and stuff like that that are having that discussion online as to whether they believe 0 to the 0th is 1 or 0 to the 0th is 0. So check it out. Check it out. All right, so the next thing we need to talk about is what to do when you have a negative exponent. Now, we're just dealing with negative integers, negative integer exponents. And this is how these things are developed. Now, most things are developed by looking forward, but what we're going to do is we're going to look back. You know, what happens if you keep multiplying this by 2 and multiplying it by 2 and multiplying it by 2? What happens? Well, we're going to instead, we're going to divide. We're going to keep dividing. So if I was to start off with 5 to the 4th, 4 to the 4th, and 3 to the 4th, 5 to the 4th is 125. 4 to the 4th is 256. I knew better than that. 256. And I messed that first one up. It is 625. What? 625. And then I was thinking about the next step. And 256, and then 3 to the 4th is 81. I know that this is 81 because 3 to the 4th is really 3 squared times 3 squared, and 3 squared is 9, and 9 is 81. So this is 5 to the 4th. Well, what happened if I divided this by 5? If I divided this by 5, I would have 5 to the 3rd, which is 125. And if I divided this by 5, I would have 25. I would have 5 to the second, because I took one of these, 5 to the second, which is 25. And then if I did that again, divided it by 5, 5 squared divided by 5 is 5 to the first. 5 to the first, which is 5, right? So same thing here. If I divide this by 4, I've got 4 to the third. What? 4 to the third, which equals 64. And then if I divide it by 4 again, it's 4 to the third divided by 4 to the first, divided by 4 to the first. 3 minus 1 is 4 to the second, which is 16, divided by 4, which is 4 to the first, which is 4. And then the same thing happens here, right? We've got 3 to the fourth, which if I divide this by 3, goes 3 to the third, which is 27. Divide that by 3, which is 3 squared, which is 9. Divide this by 3 is 3 to the first, which is 3. Now, what would happen if I kept dividing? So what would happen, and I don't have as much board here as I'd like, but I'll change it here in a second. What would happen if I divided 5 by 5? I now have 5 to the 0 power. 5 to the 0, which we all know is 5 over 5 is 1. 4 over 4 is 1. 3 over 3 is 1. So 5 to the 0th is 1, 4 to the 0th is 1, 3 to the 0th is 1. So what I'm going to do now is I'm going to establish, now that we've established how this is going, I'm going to erase this and I'm going to rewrite a few of them over here. Okay? So I had 5 squared, which was 25, and then I divided this by 5, remember? And that came 5 to the first, which is 5. And then I divided that by 5, and it became 5 to the 0, which was 1. I had 4 squared, which was 16. I divided that by 4, which was 4 to the first, which is 4. And then I divided 4 to the first by 4, which is 4 to the 0th power, which is 1. Then I had 3 squared, which is 9. Divide that by 3, which is 3 to the first, and divide that by 3, which is, this is 3 divided by 3, which is 3 to the 0th power, or 1. Okay? Now, what would happen if I divided this again by my 5? If I divided it by 5 again. If I divide this by 5 again, I get 1 over 5. And if I divided that by 5 again, it would be 1/5, but then a second 5 on the bottom, and it would be 5 squared, because it would 1 divided by 5 divided by 5. So then it would be 1 over 25. This would be 1 over 4. So I divided 1 by 4. And then if I divided it by 4 again, it would be 1 over 16. This, if I divided this by 3, it would be 1/3. And then divided by 3 again would be 1 over 9. Okay? Now, the problem comes if I've got 2 minus 1 is 1. 1 minus 1 is 0. 0, so we're subtracting 1 each time on the exponent. This 5 to the 0th, if I subtract another one, this becomes 5 to the negative first power. So let's look at this right here. 5 to the negative first power is really 1 over 5. So this is telling us instead of multiplying by 5, we're actually dividing by 5. Do you notice this is not a negative number? It's not negative. It's just that this should be on the bottom of the fraction. If I subtracted 1 from this again, it would be 5 to the negative second power. So look at these two. 5 to the negative first is really just 1 over 5 to the first power. 5 to the negative second is really 1 over 5 to the second power, which is 25. So it's really, hey, we need to divide by 5, just 1 power of it. This is telling us we need to divide by 5, but 2 of them, right? So this is 5 squared, but it's on the bottom of a fraction. This has nothing to do with a negative number. It's just telling me when I look at it that this right here, this is already a fraction, it's upside down. This is supposed to be on the bottom of the fraction. In order to put it there, I move it and the exponent becomes positive. I move it and the exponent becomes positive, and then I know what 5 squared is 25. So what is this going to be? This is going to be 4 to the negative first. And then this is 4 to the negative second power. That tells me it's supposed to be on the bottom of the fraction, and 4 squared is 16, and my negative is gone. That's the thing that's really going to bother a lot of you, is why isn't it negative? Well, it's not. That's all you need to know for right now. This is 3 to the negative first, and this is 3 to the negative second. All right. So what are we going to do with this stuff? We need to simplify these things before we work with them. If you find a negative exponent, you can't do anything with it until you put it where it's supposed to be first. So here's what we're going to do. Before you can act with exponents, you need to make sure that you've rearranged them so that they are positive. So a couple of examples that I'm going to go over. If we have 8 to the negative first, we want to simplify that so we can actually use it. And then 6 to the negative second, I want to simplify that before I can use it. And then the last one we're going to do, how about 4 to the negative fifth? 4 to the negative fifth. All right, so here we are. Well, what do I know about 8 to the negative first? I know it's not really a negative exponent. It's just in the wrong position. Instead of being multiplied, I'm supposed to be dividing it by. So I'm subtracting the thing. So it's actually 8 on the bottom, 8 to the first. So it's 1 over 8 to the first. And when I moved it to the bottom, this is no longer negative because now it's in the right position. And 8 to the first is just 8. 6 to the negative second. What am I going to do? Well, it's a negative exponent, so I need to move it to where it's going to be a positive exponent, and then I can do something with it. So the 6 squared goes on the bottom, woo, and then I put a 1 here, and this becomes 6 squared is 36. What am I going to do with that negative exponent? Well, I'm going to realize that this needs to be a positive exponent, which is 4 to the fifth. Put a 1 on the top, and now 4 to the fifth. Once I multiply 4 to the fifth, it would be 4 to the fifth, or 4 times 4, which is 16, times 4, which is 64, times 4, which is 256. And then one more time, I believe it is 1024, okay? This is a job for a calculator if you don't want to do it long, but still, you can't do anything with this thing. Move it, make it positive, and go. All right. Now, some more complicated problems await you next year where you've got negative exponents on the bottom and you've got negative exponents on the top. Well, the ones on the top need to be moved to the bottom, and the ones that are on the bottom need to go to the top. Everything becomes a positive exponent, and then you just run with it. All right. All right. That's the whole deal. So it's okay if you don't get it the first time you go through it. Many people don't. Some people just see this and go, oh, that's just supposed to be on the bottom? Okay, whatever. Others that really are wondering about this negative thing to positive, oh, how does that happen? It's okay. Don't worry about it now. Just go through the process of what needs to happen so that you can work on the problem, and then we'll talk about the idea of why it's negative later, all right? But really what's probably going to happen is you're going to realize that, oh, I just need to move this. I don't need to think about it too hard. And then later on when you're solving problems, it'll just be it'll be like a knee-jerk reaction. You're like, oh, that needs to be moved. That needs to be moved. And you'll just get it that way. All right. That's all I got right now, though. All right. I hope that helped. Hope it makes sense.